Okay, so first up, does anybody have any questions for me for the quiz tomorrow on 16 and 17?
What was the part of chapter 16 that we don't need to know? What section was that?
It's the section at the very end. So it's section, let me get there, sorry. It's section, it doesn't have like a separate title, like a numerical title like they usually do. But this whole section 16.3, you don't have to know that. And then back from 16.3, or I mean toward the front of the chapter from 16.3, you can stop at the bottom of page 328, or actually the second column on 328, replicating the ends of DNA molecules. That part about telomeres, that's out, as well as the packaging of DNA into chromosomes. That is section 16.3.
Thank you.
You're welcome. Anything about replication, transcription, translation? Reminder, have a copy of the RNA to amino acid table with you when you sit down to take the test, because there are some questions about that. The sequence of things is really important, so be sure that you, for example, I'm pretty sure there are questions like, which of the following is the correct order of events for replication of the leading strand? And then I'll list a bunch of things out of order and ask you to put them in order. And the in order will be the choices, right? Same for transcription, translation. Same for the lagging strand. So all of those like process things, definitely know the order of them, the names of all the enzymes, the functions of all the enzymes. Myself, I would start with that, a list, like for replication, I would start with a list of the names of all the enzymes and then make the drawing and remind myself of all the functions. We only see the enzyme primase. Wait, I gotta open the chat. I don't think so, Angelo. I think they're primase and the primer are actually on both strands, not just the lagging strand. We sort of underemphasize that. No, you'll see it on both strands. So, right, so when the DNA is being unwound and unzipped, like this, and those are the single-stranded base pairs there, or single-stranded bases. So there's the double-stranded DNA. And if this is the 5' to 3' strand, and this is the 3 to 5, right? So helicase here, right? Gyrase upstream here, unwinding and unzipping, or any of those topoisomerases. Primase makes that short primer on the leading strand right here. So this is the primer, the piece that I just drew. That, of course, is RNA, not DNA. The enzyme primase is going to be here just temporarily. It's not going to stay with the DNA strand. And then DNA polymerase 3, right? Not 1. One's the, yeah, DNA polymerase 3 is going to hop on like right here, right after the primer, and use that free 3' hydroxyl of the primer to start synthesizing new DNA, 5' to 3'. In the case of the leading strand copy, it's going to be toward the replication fork, right? So I put polymerase 3 here at the start of that sentence, and then here at the end of that sentence, right? On the lagging strand, so I'll give you a different strand to look at because this one's getting kind of congested there. Oh, that's bad. So on the lagging strand, trying to have more unwound and unzipped here for you to look at, right? So still helicase there, still gyrase here. Still this, now DNA polymerase 1 would have gone in and replaced that. That's why they talk about, sorry, let's make it blue. So they talk about the ends because that involves something else than DNA polymerase 1, really. But that's neither here nor there. So this would be the completed new strand here, complementary, anti-parallel, right? This is 3'. Remember, DNA polymerase can only work 5' to 3', as can all the enzymes of replication, transcription, and translation. And then I would just have polymerase 3 here. Right now, on the lagging strand, that primase and primer are going to be here. Right? Well, actually, I should draw them on the top picture first. So let's put DNA polymerase back there. Primase is making its primer on this picture at the same time, 5' to 3', right? Away from the replication fork. So this is primase making that primer. And then DNA polymerase 3 is going to hop on here and synthesize that first Okazaki fragment. So fragment A, fragment 1, whatever you want to call it. And in my second picture then, right, that first Okazaki fragment is going to be sticking out this way. That's this one, right? And then at the same time, we're going to get a second primer is going to form here because primase is going to let go of this piece of DNA and start again as more DNA opens up at the replication fork. So I'm going to get primer there and DNA polymerase 3 here. So I'm going to leave the green primer on that guy, right? Like this. That's when we have polymerase 1 come in and chop up that piece of the primer and replace it with DNA. On the third diagram, so like this, more like this. I'm going to focus just on that lagging strand, right? I would still have this first A Okazaki fragment, and now this B Okazaki fragment, and the A fragment. Notice I've made it all blue because polymerase 1, sorry, has gone in there and gotten rid of the primer, right? So now I'm going to need DNA ligase to join the two Okazaki fragments. But remember, primer B here, or sorry, fragment B here, Okazaki fragment B here still has primer on it. DNA polymerase 1 is going to jump on there and get rid of that. At the same time, that primase has laid down a third primer to start the third Okazaki fragment, or fragment C, right? And then ligase, after it finishes joining fragment A to fragment B, this is DNA ligase. Sorry, I didn't label it. It's going to jump to here after that primer is gone to seal up that gap. And that's a super short version. If you watched any of the other videos, you'll be ready to go with that, right? I don't really want to stop. I'll just go back to that, yeah. So yes, technically, sorry, I always answer your questions longer than you probably want, Angela, but technically, primase works on both strands, right? Usually in the lower grades and like high school, we just teach you, if people teach you about primase at all, they only put it on the lagging strand, and I get that. I will not be expecting you to be able to generate that picture from figure 16.18 with both of the strands working at the same time and what the active model really looks like. Come to genetics. We'll talk more about it. Well, I won't talk more about it with you, at least not in the spring. Not until fall, maybe. We'll see. Anyone else? Is the test multiple choice? I believe so. I think it is, yeah. I think there might be some short answer, but they might be, I can't remember. I think it's just multiple choice. I think it's the end of the semester and I'm tired. So, yes, I think it's multiple choice. Sorry about that. If it's not, I will send you an announcement warning later today after I look at it. But I think there's matching too. Now that I think about it, I think there's matching for like the some of the vocabulary. I think in small sets. I know most of you have learned by now not to try to take this test on your phone, but I think the matching, if there's matching, it's in small sets, like 5 to 7 items. The reason being, when I would normally do it at 15 or 20 items, but that takes too long. And also sometimes people can't see it on their screens. They can't read both sides. So I think there's some small sets of matching and multiple choice and maybe some true false, but usually in the same format, right? Like which of the following is false about blah, or which of the following is not a function of DNA polymerase or RNA polymerase. The vocabulary is tough for this one because there's a lot of fine points, and you have to think a little more carefully before you just choose an answer, because there's so many words that sound alike: transcription, translation, right? Okay. Anything else that anybody has they're thinking about, worrying about? Yes, no, maybe so. Viruses. Did you watch the video about viruses, which is chapter 18 in your book, I think? Oh, sorry, no, 19. The reason is because I did add some questions about viruses, mostly because of the pandemic, because we're, everyone's obsessed with coronavirus. So I think I did add some questions. I did part of that chapter in that video, and there are questions that go with on the quiz. So it is going to be important that you read, take a look at chapter 19 and watch that video that I did for chapter 19, because what's in the video will be what the questions are based on for the quiz. But I didn't do an outline because I just did it rather quickly. I have to write that down.
I have a question.
Yes, wait, I can't hear you.
Can you hear me?
Yes.
We had the DNA extraction lab, and then you said you were going to post a second one. I don't know. I didn't get it on my campus.
Was it chromatography?
I don't know.
I think I forgot to do that. It's either chromatography, or we only have chromatography and forensics left. I think it must have been chromatography because I have that written down. All right. Sorry about that. I will put a thing so you can upload your stuff for chromatography. I don't think I did. I don't think I actually did either of them. Did I do the one for the DNA lab? I don't remember.
You did the DNA one.
Okay. My fault there. I was having.
When do you want that to be due?
I don't really care. I mean, I shouldn't say that. How about when I'll put a due date on it of probably next Monday. That's the 1st, right?
Yeah.
Or the 30th.
Yeah, the 30th.
30th, sorry. I'll put a due date on it of the 30th, so you can work on it over the weekend sometime. I'm sure, since we can't all go shopping in person, but only online, I'm sure that we'll all have more time this weekend with our families than we really, really want. So, who said that? And then we still have the forensics lab. I gotta get all these labs in. Dang it. All right. I'll put the forensics lab for the first week of December. That Friday, whatever it is. Yeah, my bad. I was having online learning fatigue last week. I was not functioning very well Wednesday or Thursday. This crick in my neck. I feel like Donkey on Shrek. Look at my eye twitching, right? So I'm just kind of at the end of my rope too with all of this stuff. So I'm more recovered today, but chromatography, I will do that. I apologize. It's just my zone out days there. No Zoom on Wednesday. We're definitely not Zooming on Wednesday. Take the day off. And over the weekend, start watching the Darwin film because I think on YouTube it's in 9 pieces, which is annoying because that's too small of pieces. And I did try to capture the whole thing and put it up, but it was too big and they wouldn't let me. So it's called Darwin's Dangerous Idea. It is kind of long. It's about a 2-hour experience, but it covers with humans, like talking, like people, actors, I should say, not humans, actors being Darwin, his brother, Huxley, all the players that are involved in what for you would be chapter 22. So it's this awesome summary of chapter 22, and it reinforces all of the key concepts about evolution by natural selection. I would really encourage you to watch it. I do put questions on that quiz from the film. So please watch it in small bits if you want, whatever makes you happy. I put the first segment on, and then you can find the rest of them on YouTube yourself from there. Our next quiz will be 22 through 26. If you watch the film, you pretty much, and you have the notes from 22, which I made for you because I love you, right? So I have notes that are posted. I might take a few. If you didn't take them, I would have these with you, next to you, and then you could just add a few things. Not super detailed, Angelina, just like basically who a person is and what their role was in this whole thing. But I have pretty detailed notes for chapters 22, 23, 24, 25. It says notes to add 25. I have those separately, and 26 is just definitions. Yeah. Oh, I made a new one from 25. So it's a lot lighter than what we've been doing. No chemistry, right? And a lot of kind of summarizing things that we've been talking about all semester on and off. And then being like, oh, that's why it was important we learned about meiosis. Oh, that was why it was important we learned about, all the proteins in the electron transport chain are the same in every organism, including bacteria. So it's a lot of things kind of come together at the end. So please watch that while you're watching your other holiday favorites and shopping and giving. Remember, giving extra credit points for those of you that are submitting to the at least $1 to the giving fund, the student fund at the college for the marketplace. It's helped a lot of people, and of course it will help a lot more, especially during the holiday and past. I think, like right as my public service announcement, I think we're only going to see the economic impact of the virus continue to spread the longer that we are sort of sequestered in our homes and not being able to go to work or school. So if you can, please give a little bit to that fund. It helps a lot of students get through some rough times. And what else do I know? I think that's about it. Apparently, holiday shopping, Black Friday starts today. So not that I want to get rid of you, but I do have a few items that I want to pick up before before the end of the morning. Hopefully they'll still be there. Right? I know that's terrible. I shouldn't. Yeah. But, okay, anything else about the test that's on your mind? Mutations, translation, transcription, you're good with all that? I'm hopeful that you're gonna do great. All right then.